boom, boom. And now we're about to do the answers to 2C. Radio. So, what was I going on about? Okay, so we've already discussed the fact that that integral, that means integrate with respect to t. So because our variable this time is not x, it's t. How on earth do we do this again? So, one thing you could do is you can rewrite the original function first. So, rewriting the original function, because something like this looks a bit awkward. Like if you ask to differentiate, you know that the integral of 1 over x is ln x, but you're not sure what the integral of ln x is at this point, and you've got e to the power of 3t plus 4.
Integral or integral?
Integral.
Whoa! I know, but if you keep the integral, so it's messing me up. Whoa!
Integral. Integral. Yeah, integral.
Tell me what to do.
Okay, so what we're going to do is we're going to use log laws to rewrite the function.
I thought you said we wouldn't use log laws.
Yeah, log laws are kind of part of it. So how can we rewrite this? ln e to the power of 3t plus 4. Anyone remember back to third indices and logs? And way we can rewrite this function.
It will go in front of it.
Yeah, what bit goes in front?
3t plus 4.
Yeah, that kind of thing. Remember the exponent on that thing can pop out the front. So we're just rewriting the function at this point. So 3t plus 4, pop it in brackets because we're timesing that by ln e. So so we want to find the integral of that thing with respect to t. And something that we can also do one more step in rewriting the function before we integrate.
But it doesn't ln mean log e?
It does.
So log e is like 1.
Oh, that's spotted.
Thanks, Pop.
Yeah, can you just talk us through that again?
Log e equals 1.
Yeah, ln e. What does ln e mean?
It means log e.
Look, yeah.
And then log e is 1 because e to the 1 is e.
Yeah, exactly, because e to the power of 1 equals e. Well noted. So, what can we then do with this ln e?
So it doesn't appear.
Yeah, it just means 1 times 1, so pretend it's not there. So let's make a little note of this on the side. I'm just trying to write it. You probably don't have much space, so you might just want to write it small over here somewhere. So I would write like that equals log e to the power of e equals 1. And then if you want to make a note, you could say because e to the power of 1 equals e. That sort of thing. I'll put space on the side to write that.
Wait, so ln tan would be log. What would ln tan be in log form?
Plus 4 times 1. What's that, sorry?
What would ln 10 be in log form?
ln 10.
Yeah.
That'd be log
10e.
10 equals. So e to the power of 1 equals 10, which is a harder one to do. Whereas e to the power of 1 equals e, that's an easy one to do. So out of interest, what would log e to the 1 equal? E?
0.
0, yeah. Because e to the power of 0 equals?
That's just
1.
Yeah. Yeah, so just practicing some loggy stuff. So see, the fact that we knew a bit of log laws meant that we were able to rewrite the original thing to make life a lot easier. So don't forget that the question, I've just rewritten the original function, so we've still got to integrate this with respect to t. So all I've done is rewritten the function. That's why I've kept it all in blue, because it's still just the original function. And any little stuff on the side, feel free to.
Okay, so see her, right?
Yeah.
You didn't really move 3t plus 4 outside of twig. It's still inside of twig. I wrote points outside of twig, so I'm slightly confused.
What arrow?
Inside.
Oh yeah, it's just because the board's so poorly calibrated. So,
Yeah,
that's a good point.
inside of twig.
Yeah.
Okay.
Yeah, so that's right. It's because the board's so badly calibrated. So I'll do it nice and slowly.
move it to
That's better, yeah. So it's within the integral kind of sign. Thank you. Yeah, so if that was confusing, sorry, it's just because the board's a bit off, so it's kind of hard to get in the right spot. So I just did it nice and slowly. So now, see how that just made life so much easier? Now we don't have any logs to deal with. It's just a normal kind of 3t plus 4. What kind of function is 3t plus 4?
linear.
Linear. Okay. Nice. What would be its y-intercept if it was graphed?
It was what?
4. Well, is it positive or negative gradient?
Positive.
Fairy tales, what are you looking at?
There's a lesson.
They are.
You come see.
So how do you
I think
actually
she's still.
Huh?
I think you're doing both. How are you doing both?
They're multitasking.
Multitasking, okay, fair enough, yeah.
Many guys that use that.
I get you, like when we pause and that kind of stuff and we talk about other things, yeah, you can do that. Okay, so now we're going to do the integrating stuff. Now back to how do you, we integrate each of these little ones separately. So the integral of 3t. 3, yeah, raise the power, 3t squared, divide by the new power. 2. 3t squared over 2. 4t, yeah. And I've forgotten something.
What's the
Is it uppercase or lowercase in alphabet?
Uppercase.
Uppercase C in
How can you
alphabet.
tell they look the same?
They do. That one's
Wait, I
bigger.
forget this
It's
again.
bigger if it's uppercase.
What happens by writing lowercase?
It's only
one?
bigger
Means you're in
than
Australia.
cosine.
Do they care from Australia?
Probably not.
Wait, what looks the same?
Their C's.
In Australia, I'd be, instead of C, I'd be writing little C.
Oh.
There's a difference in Australia?
Yeah.
What? What is it?
I'm not,
Little C. It's a big
and
C.
whether the examiners are really fussy about that here or not, they might just not realise what you're trying to do. They might not realise you're
And really,
like an
it's
Australian style.
But our examiners don't care which one they're using. Just draw a C. Okay, don't worry about stuff. Just draw a C.
But we assume they don't know. They might, if they're really fussy and they're not aware of the fact that in some countries it's lowercase c.
Yeah. What did you say, Sarah? Yeah, because like you can't compare to other letters.
So that's a perfectly good answer. What's a way the textbook might write the answer instead?
3 over 2.
3 over 2.
What did you go?
So a textbook might write it like that, just so you're aware they're the same thing. So don't think that the top one is wrong at all. The textbook answer might tend to be that.
I don't know.
Okay, that was nice. That's such a nice question. Now we're moving on to some trickier stuff. Oh dear. Tricky. I'm going to save this before it doesn't save on me again. Sure thing. We are on to integrating some more quirky functions. Oh dear.
Bye, Catherine.
Okay. Integrating some more quirky functions.
Oh, you know that.
On the previous page, we realized that we could easily integrate. This is tricky stuff. So on the previous page, we realized that we could easily integrate something like 2x minus 3 squared. What did we do first for that one? So it was on the bottom of the... We expanded it, yeah. We foiled. Because something like a quadratic's easy peasy to expand and foil. Yes, no? Oh dear. I've probably got some spares here. I've got... Yeah, I always have a spare. So you just need... Where is it? Alright. Here we go. Just these two. So, on the previous page, yeah. So when you've got a nice little quadratic like that, you can just expand it that way. But what if we've got something a bit more higher powered? Like if you had a 6 there instead, Krista, would you be able to do that one that way easily?
No.
Why not?
If it was the power of 6,
Yeah.
of course you would have been. You tried to catch me.
I did. And then so if it was something like this to a square, I would just foil it and do it the regular way. And then integrating is useful.
With the binomial theorem.
That's true. You could do it with the binomial theorem. So that's another. If you ever had the time, yeah. If you ever had loads of time at the end to check an answer, you could do it. So if you didn't have time to do the binomial theorem, which you might not. However, what if the function was a more complicated? What's those kind of functions called again? Where it's like a function inside another function. Composite. Yeah. So composite. Wait up. So what it was, guys, can you not add extra talk these things? Composite. As I said, this is not as easy as last lesson, so really force yourself to concentrate. And so, however, what if the function was a more complicated composite function? Like 2x minus 3 to the power of 6.
Don't answer.
Or 1 over 2x minus 3 to the 5. or the square root of 2x minus 3. Square root means to the power of?
Oh, you're the smart.
Or something like e to the power of 2x minus 3. Everyone who's difficult stuff, you guys probably want to listen to this. Oh, okay, fair enough. Maybe young people can do that. Okay, 7 over 2x minus 3. 7 over 2x minus 3.
said my name.
When? What? How?
You were maybe I'm wrong. You were like, oh,
Oh, that would be on the video.
we need to play that back.
On the video.
I
I didn't say Owen. I didn't say Owen.
Wait, so how did you say it?
How did
You didn't need to focus, and then she was like, oh,
No, I didn't say Owen. I said something else. But what? Guys, I promise, I didn't say Owen. And as I said, this is pretty hard stuff, so we don't want to lose time. Yeah, I'm saying Kindle. Okay, so I didn't say it. All right. However, I said something else that you mistook for mine for Owen. Okay. So, however, it's enough. What if the function was a more complicated composite function? So, as I said, this is probably one of the yuckiest topics in here right now. So notice that for each of the composite functions above, the baby function, remember my nickname for the function inside the function, the baby function, the one that was subbed in, happens to be R. What kind of function is the one that was subbed in each of those examples?
Linear?
Linear, yeah.
Linear.
Linear.
I'd love to have the algorithm.
Yeah. Yeah, so notice that each time, in my example, I'd subbed in a linear function,
Linears again. I'm going to get the next one.
i.e. 2x minus 3. This is how you go about integrating a composite function like these, where the baby function is...
Linear.
Oh, yeah.
So you're going to get
Baby.
So you did.
Linear. So notice, remember, baby function is just my nickname for it. Don't write anything like that in your exams or an IA, or they'll just think you're insane. All right, so in our course, there is ways you can, say if there was a different kind of function in there, there's a ways you can do that, but it's not in our course at the moment. So at the moment, it's just composite functions where the baby function is a linear is all that's in our course right now. So that's nice.
Oh, you mean as opposed to
And there's a
quadratic?
yeah, as opposed to a quadratic or a cubic or something like that, because this is a specific method that's a nice shortcut if it's linear, and that's what's in our course. So example, find the indefinite integral, just means the one with a plus c on the end instead of knowing what the constant is, of this thingy. So notice it's composite. What would be the baby function? And what would be the mother function?
X to the 6.
Yeah, exactly, x to the 6. Or, sometimes we call it u. Remember from the chain rule? Similar kind of to the chain rule style, where we define the baby, and the mother we kind of talk about as being u. It's just a thing we do. So it's similar to like a chain rule, but it's for integrating instead. And it's specifically when the babies are linear. So first of all, write the function in u form, like we used to for the chain rule, and find u dash. What is u dash again? The derivative. Yeah, it's the derivative. Yeah. So this is confusing because you're doing a mixture of differentiating in order to help get the integral. So be careful about getting mixed up between those two. So first of all, write the function in u form. So the mother would be u of 6. The baby is u, 2x minus 3. U dash. Why is u dash 2? Yeah, exactly. Find the derivative. If you were just finding the derivative of this, it's just 2. Now, so these are kind of handy little things. This is just my way of kind of mapping it out. I write out u of 6, u and u dash. Now, find the integral of the function, this like the mother, in u form. What would be the integral of u to the 6?
5u5. I mean 6u5.
Yeah, you raise the power. Remember the integral? Yeah. Yes, so it's confusing, isn't it? We're going the other way. The integral of the mother would be u to the 6 over 7. Yep. Yeah, you agree with that? There would normally be a plus C. So notice there would be a plus C, but I just, so it doesn't get so too much mess, I just put the plus C on my final answer.
I'm slightly confused. Why is you have to
Yeah, occasionally you do.
U of 6. In order to do that, you have to add a number to add one to the exponent and then divide the U of 6 by the exponent. No longer confused. That's what we did all the time. Yeah, no longer confused. Thanks, Mom.
That's good. Yeah, and do you know how we can also prove it to you? So Calvina, we can also prove to you, if you differentiated this, would you agree you'd get 7u6? And then 7u6 divided by 7 just cancels down to u6. So if you did the reverse, did the reverse step, you differentiated this to get back to there, maybe you would go 7u6, and 7u6 over 7, the 7's cancel out to give you u6. Yeah, so that's a way you can test, have you integrated properly. So remember, the integral of u to the 6 would be this, but it would be plus c. But because it can get a bit cluttered if I keep putting my plus c's, I just pop, for these ones I'm just popping it at the end. So if you wanted to put plus c there too, you can, but I just pop it at the end. And then, now this is a new bit, so you already knew how to integrate. Remember with the chain rule, you kind of like found the integral of the derivative of the baby, and you times it by the derivative of the mother. Similarly, you find that it's the reciprocal of the derivative of the baby times the integral of the mother. That's the difference. It's sort of similar to the chain rule in the style. So then multiply the integral of the mother by the reciprocal of the derivative of the baby. So this is something that's new, you haven't seen. It's kind of similar to a chain rule style problem, but it's a different, you're using a reciprocal of the baby and the integral of the mother. Whereas before you were kind of using the derivative of the baby, not the reciprocal of the derivative, and the derivative of the mother. So it's new and weird, so feel free to take it in. So that's why I've defined these three things to start with: the mother, the baby, and the derivative of the mother, of the baby. Some people go straight to the reciprocal of the derivative if you want, that's also okay. But I just straight up put it there, and then I just have to remember it's a reciprocal on the next one. So multiply the integral of the mother by the reciprocal of the derivative of the baby. And then what's 1 times u of 7? Oh, sorry, so that's just the method. Then I subbed in that, the 2, times the 2 numerators, you get u of 7, times the 2 denominators, you get 14. So that's a general framework of the integral. Lastly, just sub back in the baby. Just sub the baby back in for u. And don't forget to bung a plus c on the end, because it's an integral. So it's a bit of messing around. So you kind of just eventually, like you know with chain rule and product rule and that, we kind of just have a system of setting it out. You kind of come up with a system for yourself that kind of works. So my system is I like to define the mother, the baby, and the derivative of the baby. And then I remember it's the reciprocal of this, reciprocal of the derivative of the baby, after I've integrated the mother, times the integral of the mother, and then just sub back in the u and throw a plus c on the end.
Can you explain how you got the derivative of u again?
Of the baby? Oh, yep, so differentiating back to calculus from IB1. The derivative of a constant is just 0. Like it's kind of gone, remember it disappears. Derivative of something like 2x. Remember you kind of like, so that's 2x to the 1, would you agree? So remember you take the exponent and you multiply by that. So 1 times 2 is 2. And then x to the power of 0.
Okay.
And then x to the 0 is 1, so that's why it becomes that. Yeah. It is confusing because you've got integration in your head now, which is almost like making calculus disappear, differential calculus disappear. So it's good you're asking about that stuff because it's good review of IB1 stuff. Whereas if it was something like 3x squared, it would be 6x. And if it was 4x cubed, it would be 12x squared. But these are all specific to composite functions where the baby is a linear. So integrating composite functions where the baby is a linear is in the SL course. They don't really take it beyond that.
So we would never do a non-linear baby.
It's not supposed to be.
Didn't you just...
A non-linear baby, yeah. That sounds so weird, doesn't it? But yeah, it is possible to do that, but there's a whole other weird method for that. Our course at the moment just has this. which is nice because this is a nice shortcut method that applies only when the baby is a linear. So that means we don't have to learn other yucky methods.
So the indefinite integral is the integral times reciprocal.
By indefinite integral, it just means that you've got plus c on the end. You don't know, you haven't got the constant.
Okay.
Yeah. The next topic is when you kind of learn that you can sub numbers in and actually get proper numbers as answers. An indefinite integral just means we've got the plus c on the end. So here's some more examples. Let's try this out. Notice that they're composites. And so our first step for each one, we're going to define the mother, the baby. Sometimes some people like to define the baby first. So if you prefer to define the baby in the first, that's fine. And then mother and the integral of the baby. They're three things that are useful to have. Then we're going to integrate the mother.
Wait, so the u to the 6 is the mother?
The mother, yeah. I tend to call it that, the mother. Like the overall function. And the baby's the thing.
Is the baby.
The green for me is the baby, yep. So I'll try to use those colours, yep. Green is the baby, and I'm using red as being the derivative of the baby. Pretty messed up. Okay, fine. And then we integrate the mother, and then we multiply the reciprocal of the derivative of the baby by the integral of the mother, and then sub in c and sub in the baby and put a plus c on the end. So if you've kind of got a nice way of laying it out, I don't give you much space, do I? So I do the mother in blue, don't I? So the mother I do in blue. What would be the mother?
Is it e to the u?
Yes. E to the u is our mother. What's our baby? 2x minus 3. Sorry about the formatting, but the board's funny on this side. So, no, it's just the board's funny on this side, so it's not getting me right nicely. So the mother, e to the u. I've got to write things nice and close to each other.
2x plus 3.
Yes, the baby is 2x minus 3.
This board will make me angry.
It is annoying. But it's not super bad where it's worth replacing just yet. As in, like, the one in room 8 was super bad, so that's why that got replaced. Sits on the edge of being awful. U dash, I tend to like to write out what u dash is. The derivative of the baby is. Yeah, it's going to be boring because I've always got the same function. Sorry, I probably should have mixed it around a bit. What is? I like to do the integral of the mother next. That's my favourite thing in the world. What is the? What's the integral of the mother?
Yes. EU plus 1.
Yes.
Yeah. E to the u.
Plus 1.
It is e to the u plus c. But sometimes it's not wrong if you put plus c now.
That's not what I meant.
Oh. What did you say?
Plus 1.
Oh, because e to the x equals just e to the x.
Yes, and the derivative of e to the x is just
U to the x.
Yeah. So at the moment, because of these ones,
Where's the baby?
No, it's not.
Where do you put
Use
your
the
mother? No,
so remember e to the x.
U on the e is for
This integral is e to the x plus c. So remember e to the previous page.
U.
Yes.
Okay.
Okay, so nice. So that's the integral of the mother. Normally there'd be a plus c, but as I said, sometimes putting plus c in the working gets a bit cluttered, so I just
Why do
take
we
for
need
these
the
ones I
integral
put
of
them
the
in.
mother?
Because you multiply, to find the integral of the composite function, where you multiply the reciprocal of the derivative of the baby by the integral of the mother. That's just the method. It's this new method, you've never seen it before.
Okay, I'll just go along with it.
Pretty crazy, hey? So now, yep, so the answer will be the reciprocal of the derivative of the baby. So 1 over 2 multiplied by the integral of the mother.
1 over 10. Can we put it over 1 so it's easy for
Yeah, you can write over 1, yeah, exactly. So it's easy to multiply them. And then in my last step, I times these two together, and oh well.
Don't you need to plug in U?
Yeah, I do that in the next step.
Oh, okay.
Yeah.
Is this just an EU over 2?
Yeah, if you want, just write. Do you want to write EU over 2?
Yes, it's how
Yeah, let's do that if that makes your life easier. Equals
Okay.
e to the u. That might make it a bit clearer to you. E to the u over 2. E to the u over 2 And then our last line, we're going to rewrite this with u subbed in, with the baby subbed in, and then just put a plus c on it.
I think that's worse than the first function.
It is a bit.
Yeah.
Over 2, yep, 2, yep, just plus c.
That's the worst function.
It's a bit more awkward.
Yeah.
Gee, that's good though. Okay, so that's the three things. To find the mother, the baby, and the derivative of the mother is my little system. Then I integrate the mother, times it by the reciprocal of the baby, the derivative of the baby, and then pop in u and then plus c. Kind of works okay for me. Alright. Nice. So let's define what would be the mother of the next one.
Square root of u.
Square root of u. U to the half. Yeah, exactly. Yeah. So square root of u or u to the half. Eventually you'll turn it into u to the half. I would sort of start off with like square root of u, and then I would turn it into u to the half as my second step. I don't have much space to do that, so I'll do that in one step. What's the baby?
2x subtract 3.
Yeah, so of course the baby's not always going to be 2x minus 3, but it'll always be a linear. Yep, and the derivative is 2. I should have given you a few different ones. Yeah, it's getting boring. It's 2x minus 3. Oh, you need my thing.
Why? Oh, never mind.
Having said that, I really hope I have it now. Did you see my email, Krista, where I sent my...
It's right there, right? You can walk there. So why are you red, why do you have lights,
Everyone loves it. Okay, so...
Are you going to millions of views? I don't know.
What's that, sorry?
Sent you my
Oh, nice. Okay, now you don't have to worry about it tonight. Okay, good. So what am I doing? Okay, so now, what tends to be my second step after I've defined those three things?
You have to do 1/2 times u to the half over 1. You have to do the reciprocal thingy.
Close?
Multiply this integral by...
Yeah, you're kind of doing the next one, and maybe that's too much for my brain all at once. So I tend to just do one thing first.
You write e to the u.
Yeah, I integrate the
u to the half.
the mother. Yeah. I integrate the mother, just because that's a pretty big step. That wasn't a difficult step here, because that's just an easy one. Integrating this is a fair bit of...
Why is e?
Because the derivative, the integral of...
always going to be u to the power of whatever it is. But
Remember the joke?
u to the half.
Oh.
I'll show you the joke thing that I'm going on about. This thing. Remember this one? The guy gets on the bus. I'll integrate you. I'll differentiate you.
I
So he
read
gets
that
scared.
joke out loud, and you laughed.
So Grace, remember the derivative of e to the x is just e to the x?
Yes.
Is about. And the integral of e to the x is e to the x plus c.
Okay. I think I got it.
Yeah, so which is just a special thing to do with e to the x. But that's the only function that doesn't change. The other ones do. So u to the half, we've got to find the integral of u to the half now. So remember, you raise the exponent by 1.
So it's just the 1.5 over...
Yeah. As in proper fractions, a bit better. Like
3 over 2 over 3 over 2.
u to the 3 over 2, yeah, because 1/2 plus 2 over 2 equals 3 over 2. And what do you divide it by?
3 over 2.
3 over 2, yeah. And so, see how this is a bit of messing around, because now I've got to simplify this, and then I'll do that third step after I've simplified it all. So dividing by a fraction is the same as multiplying by?
The reciprocal.
It's reciprocal, yeah. So it'll become, I'll just do 2/3 u to the 3 over 2. This makes life a bit easier for me. It's not wrong if you wrote 2u 3 over 2 all over 3. That's also okay.
Okay.
Normally we'd write plus c, but because there's a bit of messing around we have to do in this step, I like to just leave the plus c off till the end. So now we've got to multiply. What do I multiply the integral of the mother by? Sarah was saying it before.
Oh, 1/2.
Yeah. The reciprocal of the derivative of the baby. So now we've got to times that. So 1/2 multiplied by all this bizzo, multiplied by 2/3 u to the 3/2.
So if you were gonna like make it easier, would you do 2 to the u and then 3/2/3?
Yeah, you could. Yes, you totally could, yeah. Yeah, it does. It's kind of my way of doing it too.
Yeah.
I sometimes just get, and the only reason why I sometimes swap to a different one is just so you see that they're the same thing. Just so you get used to realizing they mean the same thing. So when you multiply those fractions, what would they multiply together to become?
2
Yeah.
u 3/2 over 3.
Yeah, let's write that. Sure. 2u 3/2 over 6, or 2/6u 3/2.
Plus
Seconds.
C.
Yeah, there will be a plus c. Feel free to put it in now. If you
That
want.
simplifies to 1/3.
Yeah, we need to simplify it.
So you.
And we also need to do one more thing.
So you have to sub in the u.
Yeah, we have to sub in the u. That's it. So 2/6, what does that simplify to?
1/3.
Yeah, 1/3. So you could simplify it down this way if you want. 1/3, just for your working out. Or just write equals u over 3/2 over blah blah. And then let's write our last answer. So different ways you can write it. You could write 1/3 something, so 3/2 plus c, or you can write the whole thing 3/2 over 3 plus c. So I'll show you one way you could write it. 1/3, I'm subbing in the baby now. 2x minus 3. Don't forget it's to the power of 3/2 plus c. Correct, that's awful. Scroll down a bit. Plus c. So that's one answer. That's I should just write it like
What?
that.
I did not do that. That's alright.
Or you could have just written
2x subtract 3 to the power 3/2 over 3.
yeah, and then the plus c after
Yeah.
that. The power of 3/2 over 3, then the plus c outside of that. Or so I see both are fine. Textbook tends to kind of put it like this. They tend to put their little coefficients out the front. Maybe it's easy for them to type, or I don't know. It does look easier, flatter to type, I guess. And then maybe if you need to do further maths with it afterwards, maybe having it in that form is a bit easier. So a lot of messing around. So now we're on to C. How come I can't see the bottom of my thing to scroll it over? That's because I can't. It's already scrolled over. Okay, so same thing again. We need to define. Okay, we need to define the mother, the baby, and the derivative of the baby. Interesting one. What do you think would be the mother? Yep. 7/u. And notice 7/u is like 7 times 1/u.
Said that she's just gonna walk.
Oh, really? So 7 times 1/u, because remember, what's the 7/u? Just think of its derivative, its integral of phi hat is a bit harder. So what is the integral of 1/u?
U -1 to 0 then?
Yeah.
LU?
Yeah. So remember, derivative of 1/x is ln x. Yeah, so think of it as 7. Think of it as 7 times. Yeah, 7 times 1/u. Or 7. Where are you? 7 times 1/u. Because 1/u, its integral will be ln u. Using that thing from the first page. So the integral of 1/u will be ln u. And okay, so I'll write out the baby here. baby again is just 2x minus 3. And the derivative of the baby is the same as before. U dash equals 2. So there are 3 things to find. So we can rewrite the original problem as, when it's 7 times 1 over u, you can do this. 7, the integral of 1 over u. Alright, to u. So in a way, we can rephrase the question as 7 multiplied by the integral of 1 over u.
Why would it be du?
Because I've defined it as with respect to u now. Yep. So if I could have rewritten this one as 7 integral 1 over 2x minus 3 dx. But at this point, I'd already turned it into u, so I thought, okay, just call it u instead, with respect to u instead of x. And then, nice. Oh, yep. So, what is the integral of the mother? Some of you mentioned it before.
7
So, yeah, it is overall. This is the mother. So overall, 7 ln u.
So B.
Yeah, got it. 7 ln u. So the
Wait, why can't we call it x?
Oh, because I've redefined it as u.
Why?
Once I've replaced this with a u,
Well, why do we need to replace with the u?
because it's a composite function, and to integrate it, we've got to kind of define the mother function and separately.
So we can't use x?
No, because at this point, yeah, x is fine because we've got the function defined, expressed in terms of x. But here I've re-expressed it in terms of u. So we're going to
Does
integrate
it
it
have
with
to be
respect
u,
to
or
u.
could it be like...
You can make it.
It has to be whatever the variable is. Yeah,
Just
it
what
does
we
seem weird.
use
Yeah,
with the chain rule, that's just what we use.
yeah. Because remember, I'll quickly show you on this one. This one was with respect to t, because the variable is t.
Yeah.
Yeah.
But this is x. Oh, it's because...
It's not anymore.
The rule... Yeah, okay.
You're right. It's because it's like we're doing like the chain rule for composites, but it's not technically the chain rule, but it's the same style of thinking. Okay, so Sarah just told us what the integral of the mother's going to be. So that's what I do in purple first. The integral of the mother will be 7 times ln u, which you can just write as 7 ln u. And remember, u must be greater than
0.
0. Yeah, it's impossible to have a u value because ln of a negative or ln of 0 doesn't exist. So we just have to have that on the side. It's a formality.
Over 2.
Yep.
Times 7 LU.
That's right. The reciprocal of the derivative of the baby times the integral of the mother is what happens next step. So 1 over 2, Sarah said, times 7 ln u.
7 over 2.
Yep, that's it. And then, 7 ln u over 2,
So if
or
we
a half.
write 7 LNU plus C, do we still do the U is greater than 0 as well underneath?
That's a good point. 2x minus 3 is now greater than 0. And what we can then do is solve that inequality to make it x is greater than, which is another extra thing we have to do there. Okay, so it's probably just thrown a few giggles. So, like you said, when you times these two together, you'll get 7 ln u over 2, or you could say 7 over 2 ln. And let's sub in the u. I'm going to sub in the u now to save myself a bit of time. 2x minus 3. Something I just forgot to pop on the end.
Plus C.
Plus c, good. Oops, I don't know why I just supposed to do that. Yep, plus c. And then, like Sarah said, do we still write u is greater than 0 on the side? The thing is,
Subtract 3 is greater than 0.
yeah, exactly. 2x subtract 3 is actually greater than 0, so u is 2x minus 3. And now, first of all, we've got to solve that inequality. And then that's the thing we write on the side here.
Wait,
What?
so what would you stop? Yeah.
Yeah, keep asking. Ask away. Just
So
go on the down.
No.
It's
I
hard
forgot
stuff.
the x has to be greater than 0.
Yeah, because see how we've got the functions now in terms of x? So when we state what has to be greater than 0, it's actually the x part. because there's no u here anymore, so there's no point in saying u is greater than 0. Because u, remember u is 2x minus 3?
So we just put it on the other side, so like 3.
2x is greater than? Yeah. And then x is greater than?
3 over 2.
That's it, yeah. And that's the thing that we then write on the side. Messed up, hey? Oh, hang on. No, you're right. This is when I did it, I had 2x plus 3. I wrote it down wrong. I forgot that the baby was 2x minus 3. So you've done it right. Because you forget that the fact that the integrals with ln x end up with that thing on the side. In the formula booklet they have that example of that. X is greater than 0 stuff. So that was a bit messy, wasn't it?
But I forgot to do with x greater than 0.
Oh, this bit?
Yeah.
Solving an inequality. It's just like solving. Except
And
if you
I know
had...
how you got
Oh, yeah, sorry. But keep going.
So why does it have to be greater than 0 again?
Oh, because it was to do with that stuff like ln x means log e log, what am I saying? E of x, sorry. And remember, what it means is e to the power of what equals x. So if you raise e to any exponent, could you ever get 0? If you raise it to a negative exponent, do you ever get 0? You just get closer and closer.
Okay.
Yeah, so it never goes to negatives or never goes below 0. So that's just the reason why. So we're just bragging about the fact that we know that stuff.
So why is it u?
Yeah, keep asking. It's new. Other
Okay,
probably
okay,
have questions
okay,
too.
okay.
New and weird and tricky. So that's a fair bit to click in.
Do we do as much as you wanted to, or is it?
Yeah. First of all, because see this, I'll just show you what we're going to do next, which is even the next step up from here. Shh, shh. There's another one to remember. That's a nice one. The one I showed you was the nicer one. I'll just show you what we're doing next, which I think we should start next lesson. Another type of quirky function which can be integrated is, of course, one where it is the p of a composite and the derivative of the baby. What do you think the p is going to be? What's happening with these things?
Parenthetical, I don't know.
What's the answer to? Oh, what's the answer to when you multiply something? It starts with p. The answer to multiplying is called the product. Yeah. So notice that here's a composite with a baby. What's the derivative of the baby?
8x
Yeah.
to the power.
Oh yeah. Ignore. Remember the baby's just the inside. Yeah. So it'd be 8x cubed minus.
3.
And just notice that happens to be what the function was times by.
Ooh, that's intentional.
Yeah. And same thing, like what's the derivative of the baby inside here?
3x squared plus 10x.
Which happens to be in this question what the composite got times by. Here's the baby. What's the derivative of the baby?
2x.
Oh, what's the derivative of the baby?
2x.
2x, yep. This is pretty similar. So this is just a bit trickier because we'd have to say it's a half times that. What's the derivative of the baby here?
6x. Subtract 4.
Yeah, which happens to be what it got times by. So there's another type of awkward kind of integrating, which is where you've got the product of two functions, and one of the parts of the product, one of the factors, happens to be the derivative of the baby of the composite section. And there's a special technique for that as well. And these two are the examples of harder integration that's in our course. So you just have to, unfortunately, just learn those two. But we'll stop there because this is awkward and it's going to take a whole lesson to do.